Very good morning to everyone. Welcome to my YouTube channel. Myself N. Nahalakshmi, Assistant Professor, ECE Department, Sri Shanmuga College of Engineering and Technology. Today we are going to discuss about the basic structure of embedded system. Without delay, we have to move the entire presentation part. First of all, what is mean by embedded system? So embedded system is the combination of hardware and software part. Generally, embedded system day-to-day life, lot of applications we are utilizing. For example, in the medical field, in our automatic systems and our smart sensor systems and our home appliances, in every part the embedded system is present in our day-to-day life. So before that, we need to know about the entire process of the embedded system. The first is the basic structure of embedded system. First of all, how to sense the surroundings. So we have to use some sensors. So there are a lot of types of sensors. There is IP and proximity sensors, temperature sensor, humidity sensors, and the sensors is depends upon our applications, and the sensing signal is converted into the converter part, that is analog to digital converter, and the signal is again moving to the processor part. So it is the main backbone of our embedded system, and the system then move to the digital signal into analog, and we have to get the signal from the actuator. So actuator segment is controlling for enable or disable or on and off. The purpose we are using the actuator segment, and the entire process will be stored in the memory. The memory is classified into two categories, that is one is the volatile and non-volatile memories. This is the basic part of the embedded system. And the hardware part, the main backbone of the processor, that is the controller system that execute the entire instruction what the sensor gets sensed, and the special type of sensor we have to use, that is depends upon the applications that are executed by the instructions, and the memory storage that stores the data or informations for volatile or non-volatile, for the temporary or for temporary memories. And the I/O interfaces, that is the input output interfaces, allow the system to communicate with the other devices and outside the world. And the I/O interfaces, we have to use different types of interfaces. There is also depends upon our applications, and other components of our embedded system can include some. Already we discussed the sensor is the input, and actuator for controlling our output signals, and the converter is to convert the analog to digital and digital to analog signals for sending and receiving the input and output signals. The next part is the software segment. The first one is the application software, that is our core. The data can be written in the written and to perform the specific functions. If we have to sense a specific part or specific category of our applications, that the entire signal can be written in terms of code, and the software will be included in that processor segment. And then real-time operating system, this also to improve the application, and we have to enable our application part and to control them managing the task, and when the entire program will be executed and when the program can be controlled. So the everything is under the control of real-time operating system. And these some types of sensors, there is proximity temperature sensor to sense the current temperature, and ultrasonic sensor to analyze the sound signals, and light sensor is used for some the range of light color sensor to identify the coloring, and pressure sensor, tilt sensor, vibration sensors. So these are some types of sensor we are used for our applications. And already we discussed the A to D converter, that is analog to digital converter. Since the analog signal, then the signal is converted into the form of digital for the acceptance of our processor segment. And the embedded system memory types, that is categorized in two types, that is volatile and non-volatile memory. There is a non-volatile is a read-only memory, and volatile is the random access memory. So here some types of memories we are used. And the processor and ASIC, there is the center part of our processor is the host of our embedded system, so that can be communicated to the sensors and input modules and our other network process. So this will be connected to the application and sensing the signals and connected the input or output ports, and also it will be connecting to the memory segments. And the last part of our basic structure of our embedded system is the digital to analog converter. First of all, we have received the analog signal, then it will be controlled by our processor segment, then the processor segment will be communicated to the same form, that is digital to analog converter. So the digital signal will be converted into analog form. The actuator segment is to enable or disable the analog signal, or input or output or on and off. That purpose can be done by the actuator segment. So these are the basic structure of our embedded system. I hope the video it is useful for the uh, utilization of basic structure of embedded system, and thank you.